All right, Integrated Math 3 class. This is your exam review. This is an assignment, but it's also what's going to kind of guide you through the test. So I want you to get this down carefully and understand the concepts here. Okay, so we're going to get started with a cubic function, and it says find all real and imaginary roots. Okay, so the first thing we're going to do is we need to factor it. There's two ways you can factor. You can either factor an x out of everything and come up with a quadratic, that's an x squared function, and factor that. But there's no x on the 18, so that's not an option. So the only other way we have to factor one of these is by grouping. So we're going to put parentheses around everything, around this, and then around this. And you're going to factor out whatever these two have in common. There's no number on this one, so you can't factor anything there. But there is an x squared here, x to the third. So that means you can factor out an x squared. Then x squared times what gives you x to the third? That would be x. And then x squared times what gives you negative 2x squared? That would be negative 2. Now we come over and we factor this one. There's going to be a plus sign between it, so we'll put a plus sign there. So we can factor a 9 out of here. We can see that. So a 9 comes out of here. So 9 times what gives 9x? That would be x. 9 times what gives us negative 18? That would be negative 2. Okay, so we factor both of these. And now we can see that this term over here and this term over here both have an x minus 2 in common. So we're going to put the big square brackets around it. We're going to pull that x minus 2 out. And what's left behind is this x squared and this plus 9. So we're going to put those back in the square brackets. They stay inside. Now for a polynomial or binomial like this to have, binomial meaning two pieces to it, to have real roots, you have to be able to stick some number x in here so that when you solve that, it will come out to be 0. Well, there's no number positive or negative that when you square it and then add to 9 will come out to be 0, because any number positive or negative squared is going to be a positive number. And a positive number plus 9 is going to equal some positive number. You can't get it to be 0. So that means this is going to have imaginary roots. So we rewrite it like this. You notice there's no x term here. There's just an x squared and then it goes straight to a 9. There's no x here. So you write it with an x term, and here's how you do it. 1x squared plus 0x plus 9. And then what we're going to have to do is whenever you have imaginary roots, you need to use the quadratic equation. So write that over here. Just write it out. So it's minus b plus or minus. Okay, there it is. So now you have to determine what your a, b, and c are in this equation. Well, it's whatever the coefficients are here. So a is going to be 1, b is going to be 0, and c is going to be 9. So now we just go ahead and plug the numbers in. And since it's plus or minus, it means you're supposed to do the entire calculation 2 times. One where this is a plus sign, one where it's a minus sign. But we're going to do it just with the plus sign the first time. And then the minus sign we'll just add at the end. You'll see how that works when we get there. Okay, so just convince yourself that I plugged all these numbers in based on that equation up there. So the zeros, of course, go away. So what we end up with down here is this. Now, based on what we did in 2.05, some of the principles of roots and how they work, you can write this like this. You can break that into 36 times negative 1, in other words, and then break those each out into their own root sign. And we know that this one, square root of negative 1, equals I. That's what is the definition of I is. It's the square root of negative 1. Okay, so we can simplify that. The square root of 36 is 6. I think everybody knows that. So we're going to come down here and put 6I for that. So this is 6. This is I. Over 2. which equals, you can reduce that to 3i. Okay, now to do the second part where you have to do this with a minus sign, you don't have to do this all over again. You just take this 3i, let's write it down here, and I'll put a plus sign just to emphasize it's positive, and you put a minus sign on the front of it. So with the plus sign up here, it's that one. With the minus sign up here, it's that one. All right? So those are two of the roots. Those are the imaginary roots. Now the other one is the real root, this one. And that is, what number makes this go to 0? What number x? And the answer to that is 2. So now you have all three of your roots right there. 2, 3i, negative 3i. And that's your final answer. And when you do it on the test, go ahead and put it in a box or a circle like that. I would even write the word answer or just ANS right there. Be sure it's clear, because there's a lot of stuff going on here. Be sure it's clear what your answer is. Okay, let's keep going. There was no number 2. It stated that on the bottom of the first page. And on your exam, it's going to be a duplicate. So just, unless I deleted it, I can't remember whether I did or not. So anyway, there is no number 2. Okay, now we're going to factor the following. And you're going to be able to group this one also. Again, you can't factor an x out to make it a quadratic because there's no x down here. But one thing you can check is the ratio of 6 to 2. If you reduce that like a fraction, is 3 to 1. And the ratio of 9 to 3, if you reduce that like a fraction, that's 3 to 1. When those two ratios are the same, that means you can factor by grouping. Okay? So let's go ahead and put everything in parentheses. Okay? So what can we pull out of here? Well, we can pull a 2 out of here. And there's an x squared there, there's an x to the third there, so they both have an x squared in common. And now we go back, 2x squared times what gives you 2x to the third? That would be x. Okay, 2x squared times what gives you negative 6x squared? That would be a negative 3. Now we have a plus sign here, just to separate these two. And then what do these two have in common? They have a 3 in common. So you can pull that out. 3 times what gives you 3x? That would be x. 3 times what gives you negative 9? That would be negative 3. So again, we see that we have a common term that we came out of that with. So we're going to put the square brackets around it, pull the x minus 3 out. And then inside the square brackets, we leave this and this. This problem is exactly like the last one. It really is. Okay, again, you have, that's x squared, excuse me. Again, you have an x squared plus some number. No matter what x is, whether it's positive or negative, if you square it, you're going to come up with a positive number. So there's no positive number that when you add it to 3, you're going to get 0. So it's got to be an imaginary root. Okay? So we're going to come down and do exactly what we did last time. First of all, here's one of our factors. And it's asking this time for factors, not roots. That is a factor right there. You don't have to figure out that that's going to be a 3. This is a factor. The x minus 3 or x plus 3 or whatever, x plus whatever, that's going to be a factor. Okay, so here we go. We're going to write this as 2x squared. We don't have an x term, so we're going to say plus 0x plus 3. So we have a equals, in this case it's 2. B is 0 again. And c is 3. Now we're going to write the quadratic formula. And that all goes over to a. So now just plug in the numbers here. And we're going to start with just doing the plus, not you don't do them both at the same time. Okay, so just stop, pause, convince yourself that I substituted these into that properly. So let's simplify. Negative 4 times 2 times 3 is negative 24. So this is going to be, we're going to break this into 24, square root of 24, and square root of negative 1. Again, 24 times negative 1 is negative 24, so I can break those up like that. And again, we know that that equals I. And of course, this is all over 4. Okay, so now what we have to do is, and whenever you have an I, you put it out in front of a root sign. We have I. Now what we have to do is prime factor this and see what we can pull out of the 24. So 24 is equal to 2 times 2 times 2 times 3. Convince yourself that that's true. Those are prime numbers. You can't break these numbers up any further. So what we can do to get them out of the root sign is to pair them up and pull them out. Again, this is back some of the principles I showed you in 2.05. So 2 times 2 is 4, and it's under a square root sign, so the square root of 4 is 2, so I can pull that out. So I can make this, I should put a 4 underneath this, so I can make this 2i, and then I still have the 2 and the 3 inside. You can't pair them up because they're different numbers. They have to be the same number to pair them. So 2 times 3 is 6, so I'm just going to close them back up and call that 6. And that's over 4. Okay, so we can't do anything more with this. The I is, what we can do is reduce that to 1 over 2. And the 1 just basically, you don't have to write it. So it becomes I root 6 over 2. This canceled to become a 2. Okay? There we go. That's as simplified as we can get it. Now we have to put a minus sign in front of it. Okay, so that's the plus and minus part of that. There's two roots there. Okay, now this time it's not asking us for the zeros or the roots. It's asking us for the factors. So we already have one of them, x minus 3. Okay, so what we have to ask ourselves is x. If I put this in for x, what does this have to be so that it will be 0? Well, if I put this in here, then this is going to have to be negative I root 6 over 2. So if I put that in there, that minus that would be 0. Now let's do the same with the other one. X. If I put that in for x, what does this have to be to make it go to 0? Let me make that negative sign a little bigger. Okay, that would have to be plus I root 6 over 2. So if I put that in for x, negative I root 6 over 2 plus I root 6 will go to 0. So these are the factors. So this is the final answer. All right, let's keep going. Those are the two longest problems on the test, by the way. Okay, that's the good news. Well, I take that back. There's a couple more that are that length, but most of them are shorter. Okay, here we go. We're going to factor this. So we ask, what do these have in common? Well, they have a 3 in common. 3 goes into 48. The first thing you want to check, if you weren't sure of that, probably it's going to be true. So just divide 3 into 48, see if it goes in an even number of times, and it does. It goes in 16 times. And then we have an x to the third here and an x here, so they both have an x in common. So we're going to pull out a 3x. And then 3x times what gives you 3x to the third? It's just x squared. And 3x times what gives you negative 48x? And that's going to be negative 16. Okay, so we factored it. Now can we factor any more? This is a difference of squares. Okay, perfect square minus perfect square. And you just have to remember, draw a line here, is that a squared minus b squared equals okay, so you got to figure out what a and b is. This is a squared minus b squared. So you can just put an open parentheses there, put a square minus open parentheses square. What do you have to put in there? And then square it to give you x squared? Well, it's x. What do you have to put in there and then square it to give you 16? It's 4. So that means that the a is equal to x and the b is equal to 4. So we just come up here and plug it in to get this is this, and now we want to get this. So it's going to be x minus 4 times x plus 4. So that is this factor. That will give you that. Okay, now we come back and write the whole thing, or we can do it right here. We have this 3x. Don't forget about that. You have to attach that back on. 3x times x minus 4 times x plus 4. And that's your answer. All right. Next one. We're going to factor this. It looks like, what do you do with this? X to the 4th. It's a quartic. But what you have to realize is when you have this pattern in the exponents, 4, 2, 0, you can treat it like a quadratic. And as you know, quadratics have x plus or minus something times x plus or minus something. Well, since this is an x to the 4th, it's going to be x squared plus or minus something, x squared plus or minus something, okay? It's just a pattern that you have to learn, okay? It would, to just look at that and figure that out by yourself, probably, you might not have been able to do that. But now that you know this, you know it, okay? So now what we're going to do is we need to find the grand product. That's this first coefficient and the last one. Okay, that's a times sign, not an x. So 1 times 50, so the grand product is 50. So you have to find two numbers that multiply to the grand product, and they add to this number in the middle, which is negative 15. Again, if you prefer doing this another way as far as how you figure out those two numbers, feel free to. I'm just trying to give you a logical progression, if it's not obvious what they are, how to get there. So they multiply to a positive number. That means they both must be positive or they both must be negative. Since they add to a negative number, then they both must be negative. All right, so we're going to start with negative 1 and negative 50. That's a times sign. That gives you positive 50. Negative 1 plus negative 50 gives you negative 51. Okay, that doesn't do it. We need it to be negative 15. How about negative 2 times negative 25? That equals 50. Negative 2 plus negative 25 equals negative 27. That doesn't work. We need negative 15. 3 doesn't go into 50. 4 doesn't go into 50. If you're not sure, just get your calculator and divide it and see if they go in evenly. Okay, 5. 5 goes in. Negative 5 times negative 10 gives you positive 50. Negative 5 plus negative 10 equals negative 15. That's what we're looking for, so these are the numbers we're looking for. And so they simply, since there's no coefficient here, you just plug them straight in. It's x squared minus 5, x squared minus 10. These are not difference of squares, so there's nothing, you don't do this, what you did up here. This is your final answer. All right, we'll keep moving on. Number 6. Okay, graph the following. So they give you a cubic, and they give you one fact about it. They give you a 0. The definition of a 0 is if you plug this number into the function, it will equal 0. That's the definition of 0. What that means is at x equals 4, y will equal 0. In other words, it's going to be a dot on the x-axis somewhere. So it's going to be a dot at 1, 2, 3, 4 right there, and 0 on the y-axis, which means it's right on the x-axis. If you want to prove it to yourself, plug it in. 4 cubed is 64, minus 4 squared is 16, that gets you to 48, minus 4 times 22 is negative 88, so 48 minus 88 is negative 40, and then you add 40, you get to 0. So that just verified what this is telling you already. Okay, so here we go. So what that means is if this is a 0, then this is a factor. Why? Because this, if you plug it into x, will make this go to 0. So 4 minus 4 will go to 0. So this is the factor. This is the root or the 0. If this is a factor, it will divide into this evenly. Okay, that's just what a factor does. It means it's one of the things that will divide into this function evenly. So let's go ahead and do it using synthetic division. So we have a minus 4 here. So for synthetic division, you change the sign. Becomes a 4. And then we do this. And then we take the coefficients. 1, negative 1, negative 22, and 40. Okay. And we pull the 1 down. 4 times 1 is 4. Negative 1 plus 4 is 3. 4 times 3 is 12. Negative 22 plus 12 is negative 10. 4 times negative 10 is negative 40. 40 minus 40 is 0. The fact that this is a 0 means there's no remainder, so it means this did divide into this evenly. So what this is, since this was a cubic, the quotient, the answer is going to be a squared, a quadratic. So we put a 1 there, plus 3x. You go down by 1 on the exponent, minus 10. Okay? So there we go. Can we factor that further? Well, probably. So let's go ahead and try to do it. The grand product is 1 times 10. That's 10. So we got to multiply to 10. I'm going to do this. I think I'm going to do this down here. We are going to multiply to 10. And we're going to add to positive 3. Okay, everything there's positive, so the two numbers have to be positive. So it's going to be 1 times 10 equals 10. 1 plus 10 equals 11. That doesn't work. 2 times 5 equals 10. 2 plus 5 equals 7. That doesn't work. 3 doesn't go in. 4, 2, 3, 4. I'm sorry, it's negative 10. Okay, so let's go back, check that again. So negative 1 times 10 is negative 10. Negative 1 plus 10 is 9. Negative 2 times 5 is negative 10. Negative 2 plus 5 is 3. So there we go. Yeah, it wouldn't have worked if that was positive 10. Okay, so again, try to always catch errors as quickly as you can. I just did. Okay, so it's negative 2, negative 5. So that means the factors up here are going to be x minus 2 times x plus 5. You just take those two numbers and stick them in after the x, and there you go. So now we have all three of the factors here. We have x minus 4, we have x minus 2, and then we have x plus 5. Those are the factors. So what are the zeros? The zeros are what makes each of these go to 0. So we already got this one. It's 4 minus 4 is 0. That's positive 4. This one is positive 2. 2 minus 2 goes to 0. So we go 1, 2. It's on the x-axis. It's right there. What's this one? What makes this go to 0? Negative 5. So I got to come over here. 1, 2, 3, 4, 5 is right there. So there are the three x-intercepts. Now what are the y-intercept? The y-intercept is where does it cross the y-axis, this axis, when x is 0. So what we do is we just say at f of 0 equals what? Well, if I put a 0 in there, it goes to 0. If I put a 0 in there, it goes to 0. A 0 in there goes to 0. And that leaves the only number left that isn't going to go to 0 is 40. So f of 0 equals 40. So I'm going to start here. I'm going to call each of these squares going upward 5. So these are 1, but you can have a different scale going up. So 5, 10, 15, 20, 25, 30, 35, 40 right there. So that's 40. And we should label all of these. This one was minus 5. This one is 2. And this one is 4. So an x to the third quadratic, where it's a positive and a 1 coefficient and a positive, x to the third is going to have a general shape like this. Okay, so we're going to come over here. We're going to start down here. Now notice that this point in terms of the x-axis comes before this point. This is at 0 and this one's at 2. So that means the line is going to come like this. And it's going to look something like that. It doesn't have to be perfect. As long as you show those 4 points, you're fine. You don't have to show any other points other than those. Okay? And in addition to being a test review, and we hadn't done the graphing, so I'm going to leave it to you to go ahead and do this one. All right? It's done exactly like the one up above. You know that f of 1 equals 0. I'll just get you started. So that means the factor is going to be x minus 1. So you're going to divide this into this, and you're going to do it synthetic division. You're going to come up with some kind of a quadratic. You're going to factor that. Then you're going to have your three roots. So you're going to figure out what the zeros are from that. You're going to do it exactly the same way you did the last one, okay? So this is one you do on your own. So this is for you to practice on your own, okay? All right, let's keep going. Okay, here we go. And I changed this one. I didn't like the fact that it went through kind of a in between 0 and -1 there. So I kind of fudged on it and I changed it so it kind of curves like this and goes up, something like this. It goes up through 1 right there, up through -1, and then it connects there. So we basically ignore this. Okay, I just didn't want to deal with a fraction. So this is going to be -1. This, of course, is -2 right here, this big red dot. That's -1. You can read that. And that's 3. Okay, so determine the equation for this graph. By the way, where we're going to say it crosses right here is going to be at 6. The y-intercept is going to be at 6. You can see it's somewhere between 0 and 10. And 10, we're going to call it 6. Okay, so we have our three roots, -2, -1, and 3. So we can go ahead and write three factors right away. X plus 2, because -2 is plugged in there, plus 2 will go to 0. The next one is going to be, that's a -1, so it has to be x plus 1, because you put a -1 in there, -1 plus 1 is going to go to 0. The last one's 3, so that's going to be x minus 3. Put 3 into there, 3 minus 3 would be 0. So we have that. Now, we have one more thing. We have a y-intercept at 6. That means when x is 0, y is going to equal 6. So let's go ahead and see what happens. So that means we have a factor out in front here, a. And we know that when x equals 0, y is going to equal 6. So I'm going to put that here. So we're going to put, well, actually I shouldn't put it here. I'm going to put it down here. So 0 plus 2 is 2. 0 plus 1 is 1. And 0 minus 3 is -3. Okay, so 2 times 1 times -3 equals 6. Equals -6. But we need it to equal 6 because we said that when x equals 0, it's supposed to equal +6. But this equals -6. So what do we have to do? What do we have to make this factor a to make that turn into a +6 from a negative? We have to make it a -1. Okay, so then our equation is going to be -1 times x plus 2, x plus 1, x minus 3. And that equals y, or f of x. That's the term they're using, is f of x. So there's the equation. Okay, f of x equals -1 times x plus 2, x minus 1. So again, let's go through the reasoning of this one more time. It says if the y-intercept is at 6, that means when x is 0, because we aren't anywhere on the x-axis right there, y is going to equal 6. So I put in x equals 0 here. That gives you 2, it gives you 1, it gives you -3. When you multiply those together, you get -6. But you're supposed to get +6. So therefore, this value, this value of a, has to equal -1 times -6 to give you +6. So the final equation is f of x, whatever your value of x is, equals -1 times x plus 2, x plus 1, x minus 3. Okay, we did the other one in class, so I'll go ahead and do the other one for you. Now, I kind of cheated because there it is right there. There's the answers. Copied this from someplace that already had the answers, so let's figure them out for ourselves. So here we have -3, -1, and 2. That means right away we can write our factors as, if it's -3, then it's going to be x plus 3. because negative 3 put into that spot will make this whole thing go to 0. Negative 1, so it's going to be x plus 1. Because if you put negative 1 into that x right there, it'll go to 0. And finally, it's 2, so it's going to be x minus 2. Because if you put 2 in there, 2 minus 2 will be 0. Okay, now where is the y-intercept? It's down here at, I'm going to say it's negative 6. Looks like it's crossing at negative 6 there. So what that means is when f equals 0, when x equals 0, let me write that properly. F of 0 means when x equals 0, then this is going to equal negative 6. When you're at 0 on the x-axis, that's right here, then the y-axis is going to be negative 6. Okay, so let's see what f0 into these gives us. 0 plus 3 is 3. 0 plus 1 is 1. So it's giving us the same numbers as last time almost. And 0 minus 2 is negative 2. So these are going to be negative 6. Alright? And at f of 0, it's supposed to be negative 6. So that means the a that's going to go out in front here is simply going to be 1. Because 1 times negative 6 is going to give you negative 6. So so your equation is going to be f of x equals 1 times, and then it's all these things again. X plus 3, x plus 1, x minus 2. And that's your final answer. Okay? Alright, we're going to see another one of these later in the set. Alright? Okay, that was number 7. I'm at 30 minutes. I don't want any videos to go longer than 30, so I'm going to cut this off, pick it up on the next video. We'll start with number 8.